So this is there's no more forms of a straight line other than standard, slope-intercept, and this one, point-slope. So what information do you think you need to plug into the point-slope formula of a line? A point in the slope. There you go. It's in the title. That's what you need. It's kind of like what we were using in the last lesson. We had one point, not necessarily the y-intercept, and the slope. So again, it's kind of like a different way to use the same information that we had before. Right? This is a formula. It is the slope-intercept, the point-slope form of a line. You should recognize a few symbols in there. What does the M stand for? Right? What does it usually mean when we put these little subscripts like x1, y1? What would that represent? x1, y1. It's a point. Right? It just means this is a point. You know, to be differentiated from x and y in that equation. The x and the y in the equation that don't have a subscript, those are variables. That's not like one point. Those are variables that we know there's infinitely many points. So they're not just one point. But when you put the subscript on, x1, x2, y1, y2, that means these are points. These are actual inputs that you're going to get. Okay, so we know what all these things are. They're just organized a little bit different. In fact, how would I solve that? This is like literal equations. How would I solve this for m? What do I have to do to isolate the m? What is it that's with m that we need to move? Well, this whole parentheses x minus x1, right? And how is that, what's the operation that's going on in between the m and the parentheses? So what do you do to get rid of it? You divide, right? And if you did that, this is what it would look like. M equals y minus y1 x minus x1. And that should look kind of familiar. It's kind of the formula for slope, it's just we don't have x2, y2, right? By leaving those first x's and y's without a subscript, they're variables, and that's where this form of a line comes up. Okay, so let's try. Write an equation in point-slope form if it passes through the point 4, -3, and has a slope of 2. So we should write down the formula. Y minus y1 equals m times x minus x1. Okay, so what do we need to fill in? The 2 is going to go here. -3 will be y1, and 4 will be x1. Perfect. So we write that y minus -3 equals 2 times x minus 4. Right, now if that's the whole question, that's in point-slope form right there. But I would say you should simplify just a little, right? Don't distribute. That wouldn't be point-slope form anymore. But you should simplify minus a negative. How could I change y minus -3? It's y plus 3. So don't leave minus a negative. At least fix that part of it. Y plus 3 equals 2 times x minus 4. No, because it wouldn't be in point-slope form anymore, right? The point-slope form has m parentheses x minus x1. So don't distribute it. That's the whole answer right there. Just plug in for the m and the point, and resolve a minus a negative. Other than that, you're done. It didn't ask for slope-intercept form. It said point-slope. So you've got to read what it says. If you get a question on the test that says, what is the point-slope form? Here's the point, here's the slope, and you give it in slope-intercept form, then it's like you didn't read the directions. Slope-intercept? Oh, yeah. Oh, yeah. It'll say one or the other. So go ahead and try this one. There's a point. There's the slope. Write the point-slope form. Remember, this is it. You should be writing these down. I had some notes, but if you don't look up here, that's what you're trying to fill. y minus 4, negative 2x minus negative 1. And I'm going to make one small adjustment, x plus 1. Done. Point slope. Okay, graph the equation. Graph the equation. So this time, it's not slope-intercept form where we have the y-intercept, but we do know one point by looking at that, right? What's the x1, y1? Well, remember, the formula has a minus in it. Oh, sorry. Yeah, so you got to think of it kind of like the opposite. So, in fact, the point is positive 3, negative 2. Okay? And what is the slope? And the slope is 2/3. So now we can go to this graph, go to the point 3, negative 2, and then use the slope up to, up to right 3, graph a line. So we don't have the y-intercept, but we have a point. You know, if you know the point slope form, you should be able to see the point. What's that? Okay, first you got to be able to look at this equation and tell what is the point and what is the slope. Remember, the point is the x1 is the 3. That's where that comes from. Right? The y1 is negative 2 because y minus negative 2 is like y plus 2. So if you want, just say it's the opposite. It's the opposite. Okay, and then the slope is 2/3 because that's what you expect is in front of the parentheses. So we plot the point, 3, negative 2, and then we use the slope. Up to right 3, draw a line. Right? So try to do the same thing there. Figure out what's the point they're telling you and what's the slope. Graph a line. Okay? What's the point? What's the point? 2, 1. The point is 2, 1. Remember, the minus is part of the formula. So it says x minus 2, that means positive 2. It says y minus 1, that means positive 1. What is the slope? Negative 1. So plot the point, 2, 1, and then use the slope. How do I use negative 1?
Down 1.
Yeah, I go down 1, right 1. Okay, then I sketch myself a line. Blue. Something like that. Okay, next. Okay, so now we should be able to look at a graph, especially if they've highlighted a couple points, and figure out what would be the point slope equation of the line. Okay, so let's see. We need to know two things. We need to know one point, and we need to know the slope. So how could I figure the slope?
See how much rise or run.
Yeah, I mean, since they gave us the 2 points, let's just calculate the up and down and the left and right from here to here, right? How many is it up and down? It's down 2. How much is it left and right? It's plus 2. So we know that the m is down 2 over right 2, which is negative 1, okay? And now we need to pick a point for the x1, y1. And then we've got 2 to pick from. Which, yeah, if you have a choice, try to avoid the negatives. So this will be y minus 1 equals negative 1, x minus 1. Now, what if somebody else picks the other point? Well, they're going to have a different looking point slope form, but it's still correct. So you could have 2 different answers if it says write the point slope form. If you happen to pick negative 1, 3, then you're going to get y minus 3 equals negative 1, x plus 1. Okay. Quiet. There's your you try. Okay, what is the slope? 1, 2. Okay, so 1/2. It's positive, right? It's going up from left to right, so make sure that's squares. And then use whichever point you want, right? You could say y minus 4 is 1/2 x minus 4, right? Or you could say y minus 3 is 1/2 x minus 2. Either one are correct answers. So remember, because all those points had positive coordinates, you see the minus in the formula, right? If you start seeing pluses, you know that the x1, y1, one of them is negative. Okay, write an equation of a line in slope-intercept form that passes through the point -4, 7 and has a slope of -5. Now that's the kind of thing we did in the homework last night, right? But I'm going to show you, you could actually, this is where I like to use point slope for this rather than the y equals mx plus b. So let's write the point slope form first, right? It's going to be y minus what? Which is what? Sorry. Y minus 7 equals, what's the slope? -5, then what? X minus -4, which is like x plus 4, right? Okay, but it didn't say put it in point slope form. It said put it in slope intercept form. So now solve for y, right? Distribute. Y minus 7 equals -5x minus 20. Okay, last step. Add 7. Add 7. So y equals -5x minus 13. So instead of using the y equals mx plus b to find the b, just plug it into this and solve for y. Yeah. How do I get y? Okay. Okay, so try to do the same thing. Try to do the same thing with this. Plug it into point slope form and then solve for y. And then you'll have the slope intercept form. And it doesn't matter which point. Oh, actually, we just have the one point. You know, when you solve for y, everything's always going to be the same.
Wait, do we solve for y?
Yeah, now solve for y.
It's like when you have it's like when you have like you don't allow sneakers to be what's my business?
Okay, quiet. Quiet. Here's the last slide. Okay, so you're designing a sticker to advertise your band. A company charges $225 for the first 1,000 stickers and $80 for each additional 1,000 stickers. Write an equation that gives the total cost in dollars as a function of the number in thousands of stickers ordered. Okay, let's see. What are they telling us when they tell us $80 for each additional 1,000 stickers? That's like saying $80 per 1,000. It's the M, right? They just told you the M. So the M is $80 for every additional 1,000. But they said we should count these in like the number of thousands. So that's 80 per 180. Okay, what is this? It charges $2.25 for the first 1,000 stickers. What are they telling you with that? It's a point. They just told you for 1,000 stickers, that's two. So for 1,000 stickers, it's $2.25. So now we need to write an equation. Write the equation and in slope-intercept form. So we'll start with point slope and then solve for y. Right? Y minus, what goes next? 225 equals 80 times minus 1. Solve for y. Y minus 225 equals 80x minus 80. Add 225. What's 225 minus 80? 145. Okay. So now find the cost of ordering 9,000 stickers. 9,000 stickers means the x equals 9. So how are you going to find it? Right? 9,000 stickers means x equals 9.
Oh, equals 9.
They said they want the number is in thousands. So we're going to plug in that there. Y equals 80 times 9 minus 145 and 575. So if you want 9,000 stickers, it's going to cost you $575. Okay? So write down the homework, and then you got a quiz. Yep, write this down, and we're taking a quiz.
So